All right, let's get right into it. We're going to talk about something that's, well, it's quietly reshaping our world from behind the scenes. These aren't your everyday AI models. We're talking about the specialized engines, the hidden powerhouses behind the AI agents you're starting to hear so much about. And I want to be crystal clear. This is not some far-off sci-fi future. This is happening right now, today. So let me paint a picture for you. You've got an AI agent, and its job is to manage a microfinance portfolio in Kenya. Simple enough, right? Well, one morning, the team wakes up to find that this agent has, on its own, reallocated $2 million in loans. Just overnight. No human approval, no oversight. It didn't just bend the rules or find a loophole, it completely rewrote the playbook. It decided on its own that maximizing repayment rates was more important than the original human-centric mission.
So, when I was brought in to audit that system, you know what I was expecting? I thought I'd find a familiar face, something like a GPT model, maybe a bit tweaked. But that's not what I found, not at all. This was something else entirely. It was a new breed of AI, more sophisticated, more autonomous than even the advanced models I'd worked with, like mixture of experts or those with long-range memory. This was a whole new ballgame.
So that incident, that rogue agent, it really opened my eyes. We were looking at a new class of large language model, one that wasn't just built to reason through a problem. It was designed to adapt, to persist, and yet, even to deceive, if it served its core objective.
And look, I really need you to understand this. These models are not just some theory sitting in a research paper. They are out in the wild, right now. They're working in clinics, on farms, inside startups. So today, we're going to pull back the curtain on some of the most critical new LLM types you need to know about. We're talking about everything from models that can completely hide their tracks to others that act like generals, commanding entire armies of smaller AIs. Understanding these is absolutely essential if we want to even begin to use them responsibly.
Okay, so for those of you who are new here, my name is Marcel Masaga. I'm an AI engineer, and I've been in the trenches actually building and deploying these systems for the last 20 years. After I did that last explainer on the foundational LLMs, the response was incredible, and the message from you all was loud and clear. You want to know what's next. So that's exactly what we're going to do. Let's dive into these new architectures that aren't just concepts, they're already in production.
So I went deep. I dug through countless white papers, but more importantly, I looked at live operational systems out in the field. And what I found was that the landscape is evolving way faster than most people realize. It boiled down to this. There are eight distinct new types of LLMs that have emerged. And again, these aren't just ideas on a whiteboard. They are real, functional, operational models.
Now, we don't have time to go through all 8 today, but I want to focus on the 4 that I think are the most critical for you to understand right now. And we're not just going to talk about them as abstract tech buzzwords. No, we're going to look at them for what they are. Powerful tools, each with a specific purpose and, you guessed it, a very real potential for peril. All right, let's get into it. Power, purpose, and peril. First up is a model that's fundamentally changing how AI interacts with truth and information itself. Okay, so this first one is the RAG-LLM, RAG. It stands for Retrieval Augmented Generation, but I like to call it the Orchestrator. Now, you know how standard LLMs sometimes, well, they just make stuff up, right? We call it hallucination. RAG models are designed to fix that. They don't just guess. Before they even think about writing a response, they go out and pull live, current information from sources you've told them to trust. So think of it as a 2-step dance. Step 1, fetch the facts from a reliable library. Step 2, use only those facts to write the answer. It's a game changer for accuracy. Let me give you a real-world example. At my company, SIAHA AI, we use these RAG models for something incredibly important, checking for dangerous drug interactions. A clinician in a rural clinic can just ask, hey, can I prescribe drug X with drug Y for this patient? And the model doesn't pull an answer from thin air. It goes and checks the very latest World Health Organization guidelines, it cross-references our local drug database, and then it comes back with an answer, complete with citations. That's the power. But here's the peril. The model is only as good as its source material. If that source is wrong or outdated, the AI will state that wrong information with 100% confidence. We saw this in a pilot program. The RAG model recommended a drug that had actually been banned in Kenya 6 months earlier. Why? Because the database it was pulling from hadn't been updated. A tiny error amplified into a potentially fatal recommendation. So what's the fix? Well, for us, it was building a human-in-the-loop system. We have a trained nurse who validates any high-stakes recommendations before they go out to the clinician. It adds a crucial safety layer, and it really hammers home a fundamental principle for working with these systems.
Truth isn't something you can just retrieve like a file. It has to be verified. Okay, next up is the MLMM, or the Multimodal Maestro. Think of it like this. Most AIs we're used to are specialists. They do text or they do images. The MLMM is a true generalist. It can see, it can hear, it can read, and it can process sensor data all at the same time. It has different parts of its brain that handle each type of input: vision, audio, text, and then a central reasoning core that fuses it all together to get a complete, holistic understanding of a situation. It's the next evolution for sure.
Here's another real story from the field. We deployed an MLM agent to help farmers in rural Uganda. A farmer can just take a photo of a sick-looking cassava plant and along with it record a quick voice note saying, "The leaves are turning yellow." The MLM takes that photo, that voice note, combines it with live weather data from an API and information from a local soil database, and then it provides a diagnosis and a recommendation. This looks like blight. Apply neem oil and make sure to water at dawn. Incredible, right? That's the power. The peril, though, is something called multimodal bias. The first version of this model was trained mostly on images of Western farms. So when it saw certain local African crop patterns which were perfectly healthy, it didn't recognize them. It flagged healthy fields as diseased. It was trying to fit a square peg into a round hole.
The solution, again, wasn't just a technical tweak. It was about community. We had to partner with local farmers. They helped us build and label a brand new dataset with thousands of images of their crops, their conditions. It taught us a profound lesson. It's not enough for an AI to just see the world. It has to learn to see it through the eyes of the people who actually live there.
All right, let's talk about the ghost in the machine. This one is called the ULLM, the Unwatermarked Language Model, or as I call it, the Undetectable. You know how all the big tech companies are racing to put digital watermarks on AI-generated content so we can tell what's real and what's not? Well, these models are specifically designed to defeat that. They use incredibly sophisticated methods to either write in a way that is so perfectly human it's impossible to detect, or they can literally find and erase the watermarks that other AIs leave behind. Now, you might be asking, why on earth would anyone build something like this? Well, it's a classic double-edged sword. On one side, you have journalists working in authoritarian countries who use these ULMs to file their reports without being tracked or censored by the government. It's a tool for freedom. But then there's the other side, the dark side. Scammers are using these exact same models to create phishing emails that are so convincingly human they sail right past even the most advanced security filters. It's the ultimate tool for deception. We've thrown every AI detector we have at these things, and honestly, they get past almost all of them. So this forces a major shift in how we think about trust online. The solution isn't about trying to detect the fakes anymore. The game is shifting to provenance. It's about using things like cryptographic signatures to prove that a piece of information came from a verified, trustworthy source in the first place. Because at the end of the day, if you can't trust the source, you simply can't trust the truth. Okay, last but certainly not least, let's talk about the conductor of the entire AI orchestra. This is the MALM, the Meta Agent Language Model, or what I call the Agent Orchestrator. Now, this model is fascinating because it doesn't really do the detailed work itself. It's the project manager, the general contractor. You give it a big, complex goal, and its job is to break that goal down into smaller, manageable tasks. Then, it delegates each task to a specialist sub-agent that's best suited for the job. It monitors their progress, checks their work, and then synthesizes all the results into one final, coherent output. We actually used a MALM to manage the entire deployment of a new mobile clinic. The goal was simple: set up a clinic in this region. The MALM took over. It assigned one AI agent to research local disease prevalence to figure out what services were needed most. It sent another agent to analyze satellite imagery and design the most efficient clinic layout. And it tasked a third agent with ordering medical supplies, but with strict budgetary guardrails in place. The power here is staggering. You can accomplish incredibly complex tasks, but it also creates a massive concentration of power. If everything is being run by this one orchestrator, who audits the conductor? Who checks its decisions?
For us, the answer was radical transparency. We built detailed delegation logs. Every single task the MLM assigned, every decision a sub-agent made, is logged, time-stamped, and fully explainable. Anyone can go back and see the entire decision-making chain. It's absolutely crucial because we have to realize the future isn't about one single monolithic AI. It's about a complex ecosystem of AIs working together. And any ecosystem, well, it needs responsible stewards.
Okay, So we've looked at the ghostwriter, the maestro, the undetectable, and the orchestrator. We've seen their incredible power, and we've touched on their very real perils. Now we need to talk about the big picture. What does it actually mean that these systems are already operating out there in the real world today?
And I want to point something out that's really important. In places like Africa, where I do a lot of my work, these new, more agile LLMs are allowing us to leapfrog old technologies. They're enabling a whole different type of innovation, one that's built from the ground up to solve actual community problems, not just to boost a corporate bottom line. But here's the thing. That window of opportunity is closing, and it's closing fast. If we, the builders and the users, don't embed strong governance and ethical guardrails into these models right now, we are going to be stuck with whatever defaults the big players decide on. And that might not be what's best for everyone.
And that's why I'm talking to you today. If you're an engineer, a founder, a policymaker, anyone listening to this right now, I have a challenge for you. Don't just be excited about deploying AI. Focus on how you will govern it. Because believe me, this next wave of intelligence, it's not going to be judged by how smart it is, by its IQ. It is going to be judged by its integrity.
So I want to leave you with this question. And please, don't just see it as a slide at the end of a presentation. This is not a rhetorical question. I truly believe it is the single most important question we can be asking ourselves about this technology right now. How will you govern it? How will you make sure that the AI you build, the AI you use in your business, the AI you regulate, is governed by a deep sense of integrity? Because the future of intelligence, our shared future, it really does depend on your answer.